Descartes' rule of signs looks at number of variations in signs, so sign changes, to find the possible number of positive or negative real zeros. So I'll show you how to do that in these two examples, but I will also come up with another one because I think we need maybe one more. Okay, I'll show you three examples. So if you want to find how many positive real zeros a function p of x or polynomial p of x can have, you have to first find the number of variation in signs. So sign changes. So let me do the positive cases first. So here's a function q of x. I'm going to rewrite q of x, okay? The first term is positive 4x to the fourth power, right? The next term is positive 2x squared. The third term is positive 5x. The last term is positive 7. Did you notice that this polynomial, this function, does not have any sign changes, right? All signs are plus, plus, plus. So sign did not change at all. So no sign change. No signs changed. If that happens, the possible number of positive real zero has to be 0. Okay, it's not gonna have any positive real zero. I'm going to show you another one. I'm going to go and do the positive real zero cases first. So when there is no sign change, you're not going to have any positive real zeros. How about this one? I'm going to write down q of x, which is negative 4x to the fourth, minus 2x to the third, minus 4x squared, minus 6x plus 7. I'm going to highlight all the signs. Minus to minus didn't change. Minus to minus didn't change. Minus to minus didn't change. But look, minus to positive. Sign changed once. So one sign change indicates that 1 is a possible number of positive real zeros this polynomial can have. Okay, I'm going to show you another case because there was one more part. It says that the possible number of positive 0 is equal to the number of variations of signs of p of x. That's what we did. If there was no sign change, we said 0. If there is one sign change, we said 1 is a possible number of positive real zeros. But there is a second part that is worded a little bit confusing way. In a confusing way, it says less than that by an even number. So what you have to do is start with that number you find, however many sign changes you find, but you're going to have to subtract 2 until you get 0. Okay, this part is confusing, so I will show you how to do this by showing you another example. So if I add another example, maybe after this slide, this page. I don't know if you can hear my dog snoring. Okay, so I'm going to add another example called q of x. Q of x, I'm going to say this function starts with the positive 2x to the fourth, minus 3x to the third, positive 2x squared, minus 5x, plus 7. Okay, so if I'm looking for the, let me just copy down the wording of this. If I'm looking for the possible number of positive real zeros, I have to check for the sign changes. Sign change from positive to negative once. So there's one sign change, right? Next, sign change from negative to positive. That's another sign change number 2. Sign change from positive to negative. So that's sign change number 3. And lastly, negative turned into positive as we went to the next term. So how many sign changes? We have 1, 2, 3, 4 sign changes. 4 sign changes. In that case, what you're going to have to say is possible numbers of positive real zero. It starts with 4, but what you have to do is you have to go down by an even number. The smallest even number is 2. So go down 2 from 4, which is 2. If you're not at 0, we go down 2 again, okay? We go down to 0. So possible numbers of positive real zeros are 4, 2, and 0. Now look, if you have, for example, another example, if you have 5 sign changes, in case you have 5 changes, then the possible number of positive real zeros is going to start with 5. It's going to go down to 3. It's going to go down to 1, but you can't go below that because the one after that will be -1, and you can't have negative number of possible numbers of positive real zeros. So that's what they mean by less than that by an even number. So you know how to find the possible number of positive real zeros. Let me now show you how to find possible number of negative real zeros. To find the negative real zeros, or number of negative real zeros, you have to find q of negative x first. So plug in negative x into the function. 4 times negative x to the 4th plus 2 times negative x squared plus 5 times negative x plus 7. And you need to just simplify this very carefully, all the signs. Take a look. This circled part, you see negative raised to the 4th power. If the exponent is even, it's going to come out as positive. So I will have positive 4x to the 4th power. Next, negative x squared, that's going to come out as positive 2, right? So I will have plus 2x squared. But look at these two. If I multiply 5 times negative x, you agree that is minus 5x, right? And I just need to bring down that plus 7. All right, let us find the number of sign changes now. Positive to positive, no change. But, ooh, positive to negative, we found the sign change. There is one sign change here. And let's see, from this negative, the next term is positive. So guess what? We found another sign change. So we say that this q of negative x has 2 sign changes. Or I think they called it variations in signs. I will say the possible number of negative real zero is 2 and go down 2 from it, 0. It can have 2 negative real zeros or it can have 0 negative real zeros. Okay, so now if you think about this will have a total of 4 zeros, right? What we are saying is maximum of 2 real zeros. So the other 2 must be imaginary. All right, so let's do another one down here. I want to find the possible number of negative real zeros. So plug in negative x first and simplify the signs. Negative 4 times negative x to the 4th minus 2 times negative x to the 3rd minus 4 times negative x squared minus 6 times negative x, such a long function, plus 7. All right, I need to simplify all these signs now. If you take a look at this part, let me use a gray pen. That will come out positive, right? So this will remain as negative 4x to the 4th. But look at this part. That will come out as negative. But you know, negative times negative will give us positive. So this term right here, that will actually turn into plus 2x cubed. All right? When I do the gray part, that will come out to be positive. So this minus 4x squared will keep its minus sign in front because there was a no. Yeah, if this comes out to be positive, it needs to stay as negative, that negative 4. All right, how about this? Negative 6 times negative x. That will give us plus 6x. And just bring down that plus 7. Now let's look for the sign changes. Okay, let's look for the sign changes. All right, negative became positive. We found one sign change, 1. Next, positive became negative. We found sign change number 2. Negative to positive, so that's another sign change. But the last one, positive to positive, that's no change. So how many changes do we see? We found 3 sign changes. So it can have 3 negative real zeros or 1 negative real zeros. And I got 1 from 1 is 2 less than 3. So you have to list both 3 and 1. It will be wrong if you just say 3. Okay, so let's do the last one, the one that I created. I want to find the number of this is just an extra example that I made up, but I think we should do it. All right, hold on 1 second. Let me make some room real quick. Okay, that's good. And I need to copy this blank to write my answer. Okay, so to find the possible number of negative real zeros, what do you have to find first? Q of negative x. So I need 2 times negative x to the 4th minus 3 times negative x cubed plus 2 times negative x squared minus 5 times negative x plus 7. So these two, the negative x to the 4th will come out positive. So the term is positive 2x to the 4th. This will actually come out to be negative. The orange circle, this piece right there, will come out negative. It's going to meet the negative in front of it. And together they will become positive because negative times negative is positive. But this third term, though, when that comes out positive, we have a positive 2 in front of it. So the entire term is positive. What about these two? Negative times negative is positive. And I bring down that plus 7. Now let's take a look at the sign change. The first 2x to the 4th, you agree that is a positive term, right? Let me highlight all the signs here, okay? Plus, and plus. No sign change. No sign change at all. So guess what? The possible number of negative real zeros must be just 0. So that is Descartes' Rule of Signs and 3 different examples to get you started. You do have a homework topic on this in ALEKS, so go and practice this for me. I will be back to go over another page, I think page number 4 in another video soon.